Hello and welcome back to lesson 3.2. Well, not welcome back to the lesson because we've never done this one before, but welcome back to the channel. Yeah, we're going to examine features of diagrams to determine the story of how the diagrams are built. Kind of look at the logic of the diagrams. Logic. Write a paragraph to prove a conjecture that surfaces when analyzing a diagram. So conjecture is like something you think is true while you're analyzing, but then you prove it. So it's proven to be true. Once again, using logic. Okay, let's skip all the highlighted ones. You can read them for your your own personal enjoyment. Still learning how microphones work. Okay, in the previous task, how do you know that? We saw how the following diagram could be constructed by rotating a triangle about the midpoint of two of its sides. Yep, starting here, rotate around there, rotate around there. We did this in class. We built these. The final diagram suggests that the sum of the three angles of a triangle is 180. This diagram tells a story because you saw how it was constructed through a sequence of steps. You may have even carried out those steps yourself. Yes, we did. Sometimes we are asked to draw a conclusion from a diagram when we are given the last diagram in the sequence of steps. Let me read that again. Sometimes we are asked to draw a conclusion from a diagram when we are given the last of the diagram's sequence of steps. I don't like the way they wrote that. Put a possessive S here and get rid of the N. Diagrams, sequence of steps. We may have to mentally reconstruct the steps that got us to this last diagram so we can believe in the claim the diagram wants us to see. There's a diagram. Let's analyze this diagram. B is a center of a circle. A is a center of a circle. It doesn't say that anywhere, but I think same diagram, and the first thing they say, A and B are the centers of the two circles that intersect at that point C. And some other point down here, we could say D. What can you say about the triangle in this diagram? Pause and reflect. No, I mean, what do you think? What type of triangle is that? What kind of triangle is that? And why do you, and start to think about why you can say that. 2 minutes later. It's equilateral. All three sides are So here's the biggest clue. B and A are centers of circles. They're linked with this length. That's a radius of both. And if two circles have the same radius, they're the same size. And so this length from B to C is also a radius, but we know it's the same size as this because it's the two radiuses of B. This is a radius of B circle, this is a radius of B circle, but also we know this is the same size because it's a radius of the A circle, which is the same as the B circle, and it's a radius of A circle. Circles are named after their center points, by the way. What convinces you that you can make this claim? What assumptions, if any, are you making about the other figures in the diagram? The other figures in the diagram. We already talked about this because we talked about how the circles are the same. See, we were just supposed to talk about the triangle up here. It's equilateral triangle. But then we went on to explain why, because about the circles we said about the circle stuff. There's something out in the hall making a noise like a giant vacuum. What's going on? The janitor's catching up. And finally, what is the sequence of steps? Well, there's different ways to start it, but there's definitely one way to finish it. Like what happened, what was the last thing in this diagram? Okay, look at all the lines, the dotted lines, which could have been made by a compass, the A point, which could have been pointed at, the B point, which could have been founded, and the C point, and the lines that connect the three. What of all those was the last thing? Think about that. What was the first thing? See if you can figure out the sentence. Go ahead and pause here. Pause and think. Do 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 do. 2 minutes later. Well, the last thing is connecting C to B and C to A, because you can't find C until you have both circles. Well, what do you have to have the circles? Well, the one circle could have just been drawn immediately. Or you just put the pin down and make a circle. That's something you could do first. So you in that regard, you kind of find point A. And then you would just pick point B on the circumference of circle A, and then you can make this line that connects the two. However, another option is just to make a line AB and put circles with the radius of the size AB on the endpoints of the segment. But either way, it is only then that you can locate point C and draw segment AB and segment BC. So segment AC and segment BC are the last things that happen for sure, no matter how it gets started. So, sequence of steps for the diagram. Segment AB made. Either point A is selected and a circle made, and then point B on circle A circumference is chosen. Oh, and a circle made. The B circle. This is getting to be a lot. Or segment AB is made first. Then two circles with radius, length. Now you're expecting a number to come next, right? Lengths are numbers. Well, here is your number, the number AB. Wait, that's not a number. That's two variables. No, not in geometry. That is the length between AB. Remember, if it has a hat, it's the segment itself, the physical object. You know, the actual line segment, if it has the hat. If it's just the letters A and B, it stands for the distance, a number, some number of distance between them, whatever unit, doesn't matter the unit. This stands for the distance, and so that radius is that length. What is it? Doesn't matter. This is what the book is talking about when it says reasoning from a diagram. When the specifics don't matter, specific measurements don't matter, Specific lengths don't matter. No matter what they are, it still works. And when no matter what they are, it still works, you want to use some symbols for that distance, no matter what it is, because it doesn't matter. Then you use the endpoints, and that stands for the number, the length of between those endpoints, no matter what it is. Doesn't matter what it is. Doesn't matter what it is, we're about to make 2 circles of that. So you can, doesn't matter what it is, but you can still put your compass to that size, whatever it is, like make any line, then put your compass to that size. Doesn't matter. That size, AB size. Okay, rant over. Then 2 circles with radius length AB are made with centers at A and B. Sometimes people write the word point before they put a point letter, but sometimes they don't. Sometimes they just say the letters, and that just means the point. And B. In any case, either case 1 or case 2, either way, point C is then located. We couldn't find it before, but now that the circles are there, we can, because it's where the circles cross above the line. Point C is then located. And finally, segment AC and BC can be constructed. Okay, we got it. We got there. So no matter how it starts, those 2 segments are going to be the last things made, because you can't make them until you know where C is. You can't find C until you have the circles. You can't make the circles until you do one of the 2 things at the top. All right. Sweet. What can you say about the triangles, quadrilateral, or diagonals of the quadrilateral that appear in this diagram? List several conjectures that you believe are true. And we are given the fact that circle A is congruent to circle B. So just like last time, they are overlapping. This is a radius of both. We know that they're congruent, so we know that this is connecting their centers. Technically wouldn't even need to be given that information because it's obvious from the drawing. But what can we say? Can we say anything? Do we have any rhombuses? Do we have any right triangles? Do we have any equilateral? Well, we know there's an equilateral. This is the same diagram as last time, so we know there's an equilateral. And just like last time, those things we described that would have to happen first, they would still have to happen first. And then more things could happen after that. Let's see, once you have the 2 circles, you could draw that line. We still know AB is the first line, because there's no way to set these circles up exactly correct unless you start with AB. Dink. These can start connecting. Well, you have to locate C and D. And so we're dealing with pretty much the same thing. Okay, so, but let's make some conjectures. That's what they want. Conjecture, conjecture. Well, these 4 look the same. It might be hard to prove, but let's conjecture it anyway. We don't necessarily have to prove it. Triangle CPA is congruent to C. Oop, forgot the triangle symbol. Triangle CPB is congruent to triangle DAP. It's congruent to triangle. Running out of room. DPB. Okay, so those are the 4 minis. It's a conjecture. There's these long triangles, these long skinny triangles. Tall. Let's call them tall. I don't know. A triangle CAD is congruent to triangle CBD. Time to get out the trusty colored pencils, which just happen to be connected to compasses, which is awkward. That's okay. Talking about that triangle, that's the CBD. And this triangle. Those are congruent. So I want you to come up with 3 more conjectures. You don't have to prove them. They just have to be ideas that you think could be proven with some time and effort. Make a conjecture about this quadrilateral. What kind of quadrilateral is that? How could you know? How could you prove? Could you use radiuses of circles since the 2 of those corners are centers of circles? Okay, what else? We have the first triangle we looked at in the last diagram, and it looks like a mirror image. Could you make a conjecture there? Ooh, how about the diagonals of the quadrilateral? How do they meet up? What's the nature of these guys' relationship? What's happening in here? What are those angles? What are these distances? Okay, 3 more conjectures. I'm going to check those in your uploads. Please talk to me if you need help. Two minutes. Data. Here are some possible conjectures you might have made as you thought about the construction in the previous given diagram. Select one of the following statements and write a paragraph that would convince your partner that the statement is true, thus proving it. Your partner should work on the other statement, then work together to revise and refine each of your proofs. I want you to go ahead and work on both of these. These would start with like because, and then say some stuff. And then once you're done, show me, and I will partner you up with someone in the hall. You might have to wait. You don't have to write this. In the hall. To talk it out with a partner. I give up. Together with your partner, select one of the following conjectures and write a paragraph convincing someone else that your conjecture is true. We're going to skip this. Maybe we'll come back to it later. And that wraps this up. So now, because we're skipping that, I want you to take your time on these. Focus here, because we're skipping that other thing. All right. Ready for more? Yes, but that's for yourself to explore. Takeaways. This is when I remember that half of you have a different packet. Let's see. Yeah, you can still do this all. But now that we're to the takeaways.
Mr. Murray?
Working on with diagrams is central to geometric thinking. Like any other text, a diagram is written by an author and has to be read by a reader, since every diagram is intended to tell a story. That is to say, a diagram has a purpose. Is a tool for thinking. Is a tool for communicating. And finally, is built in successive steps, each depending on previous steps. Nailed it. Here are some things to keep in mind. Base angles of isosceles triangles are, in other words, in those triangles where two sides are the same, isosceles, two angles are the same, the base angles. The diagonals of a rhombus bisect each other. It's okay if these aren't any of the things that you wanted to prove or conjecture. These are conjectures now. The diagonals of a rhombus are perpendicular. Oh, I should use the perpendicular symbol. Perpendicular, quote unquote, that. And the diagonals of, these quotes mean the same words as above. Bisect the vertex angles. Pretty cool things to think about. Here's your lesson summary. Depending on previous steps, when we tell the story, we identify additional features, blah, blah, blah. Today we wrote a paragraph proofs that are things we noticed. And stay tuned for next time. Okay, you guys have been great. Take it easy.